Okay, I'm back with you. My wife called on the telephone and I felt like I better take that so I wouldn't get in big trouble at home. Okay, so let's see, we were talking about these various turbines and high pressure, medium pressure, low pressure steam. So you can see, where the steam comes in, steam comes out, and where it goes. So, I think this starts becoming self-explanatory after you work your way through it. I guess we're showing a couple of electric generators here, electric generator here, or they could be air compressors. It doesn't really matter for our discussion. We're showing a pump being driven here, another pump here. Here we've got high pressure steam heating the fluid. We've got the steam trap pass into a flash tank. We get some flash, some medium pressure flash that goes into the header. The condensate then is controlled flows down to this lower pressure tank. So we get some more flash out of that. And this lower pressure tank is also receiving the condensate out of this heat exchanger down into here. And then we've got another heat exchanger over here utilizing low pressure steam, another fluid in and out, another trap, atmospheric pressure, flash tank, losing some steam to atmosphere. All the condensate is going to flow into this and then get pumped back over to the deaerator where the makeup water comes in. So hopefully you're starting to get a little bit of a feel for at least how things flow through the system. And here is, I think this is the last one of these, and it's all the same sort of stuff. What we have added over here is a condensing turbine. So this is taking high pressure steam, and this device is indicated to be a condenser, which could operate at very, very low pressures, even sub-atmospheric, in order to get the biggest pressure drop possible across the turbine, which will maximize the amount of power we can get out of the turbine or electricity out of the generator. And then this would be a cooling media. Typically, it could be cooling tower water or it could be lake water that's circulated through here to condense the steam, the very low pressure steam that's coming out of the exhaust of this turbine. And then that also gets returned to the condensate receiver tank, which then goes to the deaerator, receives makeup water, and kind of the same story as before. Okay, so now that's kind of our introduction, just to let you see a little bit what steam systems look like. We'll go into some of these other topics. This is kind of the focus areas of the course. So under steam generation efficiency, boiler efficiency is a major factor determining the operating cost on the steam system. If we can combust the fuel efficiently and generate steam with that heat, that's going to go a long way towards minimizing the cost of operation. What are some major factors that impact boiler efficiency? We will be talking about those. And for a particular plant, if you're called in as a consultant, you have to go through all these various parameters and evaluate them, see how well they're doing, make suggestions, that sort of thing. The pie chart here shows the overall cost of owning and operating a steam system. So we see 75% is fuel. So if you can improve your combustion efficiency by 2, 3, 4%, that can turn into a lot of money over the course of a year or the lifetime of a boiler. Labor, you got to have guys to operate things and clean things and check things and do all that. Depreciation, electricity is used for fans and pumps typically. Water treatment chemicals, sewer charges. We put some flows that we haven't talked about yet that get put down the drain, and we have to purchase some water. So those are kind of the costs that we wind up considering. Resource utilization, and that says effectiveness, but I got my little camera over it, sorry. Steam is generated for many purposes, can be generated from different primary energy sources. We can consider natural gas, fuel oils, sometimes waste wood. Coal gets used in a lot of cases on big boilers. So the question is, which one of these do we want to try to use? How do we prioritize which ones cost more, which ones cost less? So that's kind of what this is looking at. Also, there's a topic, cogeneration, which indicates typically that we produce steam, and then we might make electricity from the high pressure steam, and then after we go through some back pressure turbines, we get lower pressure steam that we use for industrial heating purposes. So that's two useful outputs from one energy input. That's cogeneration, or it has another term, combined heat and power. And we will be talking about some of those concepts as we go through the semester. Distribution system, what are the losses? What can we do to improve efficiency, reduce operating cost with the distribution system? Okay, so why do we want to change anything? What's the main driving force for change? Guess what? It's the almighty dollar. And so that's what drives, in industry, that's what drives just about everything. Businesses are there to make a profit, and anything we can do to enhance that efficiency goes to the bottom line, and that's what drives projects and implementation and improvements in systems. Now, all of these things, can be listed, and most of them will translate into dollars change or regulatory restraints. So we see, energy, we want to minimize that. Reliability, nobody wants to be down, have the plant down when you're not producing anything. Reduce maintenance costs, productivity, all of this. And emissions reduction, that can turn into dollars because you can get fined if you don't maintain your emissions within the prescribed levels by the environmental agencies. And there's an old adage in the energy efficiency business: if you're not managing what you do not measure, or you got to measure it in order to manage it. So measurements are very critical in all of this. Okay, let's move on into the introduction a little further. I'm not sure that this is still distributed, but it's a pretty good document. Or it was actually an Excel sheet. It was put out. You can see this one's listed 2002, version 2, Department of Energy. And what this was an Excel sheet that was circulated to anybody. It was downloadable. I mean, it was free. Basically, it's a questionnaire where you give yourself points. It's like a big self-evaluation for companies that operate steam systems. And we'll clip through it a little bit here. I don't want to spend too much time. But what it's really, there's a lot of good things that come out of looking at this and evaluating yourself. But it asks a lot of questions that people may not be considering or may not be doing a very good job at. Certainly if they're not considering them, they're probably not doing a good job. And so, what it does, it gives us a certain number of points in each category, and then the user of the system was to assign his own score. So however well they thought they did. So this would be 10 points, so that would be a 0 to 10 scale. And you can see all of the different categories, and just considering the categories has a considerable amount of power for people that operate these systems. So, for example, steam system profiling, steam cost, measure fuel cost to generate steam. Do you actually measure the fuel cost? Or how do you come up with that? Maybe, if all your natural gas goes to the boiler to make steam, then you've got the gas bill once a month, and you figure the utility is probably pretty good at measuring gas flows. So you get that. But if you bring gas in and you split it, 5 different ways, and one line goes to the boiler, but the other 4 go to other types of gas-consuming equipment, then you really don't know what portion of your total bill goes to the boiler. And so that would then indicate, well, maybe we should put a meter on the boiler. So then we do know, and we can quantify, and we can get some hard data on how much gas we're burning in order to produce steam. Do you trend fuel cost to generate steam? Do you plot it up on a regular basis? Do you, every month or every week, do you have an Excel sheet where somebody looks at this? Steam product benchmarks. Measure steam and product. You know, do you have a certain, for whatever you produce, if you produce, I don't know, a plunger to clean out your toilet, then you have to make steam to drive your process. How many pounds of steam does it take to produce a plunger? You know, well, do you calculate that? Do you know what it is? Do you trend it? And do you pay attention to it? Steam system measurements, measure, record steam system critical energy parameters, oxygen flow, make-up water flow, all kinds of things that, you know, what kind of job do you do measuring and tracking those parameters, and the intensity of measuring steam flows, all kinds of things. So we'll, I don't want to spend too much time right now going through all of these. Hopefully as we go through the semester or go through this module of the course, it'll be probably roughly a month, you know, 3.5, 4 weeks, and then we'll have a big test over it. You'll come to appreciate all of these things. So, you know, but you can just see things like steam trap maintenance, water treatment. How well do you do at controlling the quality of your feed water and your boiler water? Insulation. You got steam's hot. You need to insulate it for personnel protection and to reduce energy loss. Steam leaks. You go in some plants and there's little puffs of steam coming up all over the place, and you go, wow, don't these guys ever fix a steam leak? Water hammer, where if you get water in the steam lines, that steam's moving fast. It can grab a chunk of water and, you know, move it down a pipe 400, 500, 600, 700 feet per second, and when it hits something, it's a big bang and it can break things. So is water hammer a problem, and how well do you manage it? Moving on, boiler efficiency. Do you measure it? Do you have online equipment where you continually measure it? Do you do spot checks? How often do you do it? How often do you tune the boiler in order to keep its efficiency under control and at a good level? Heat recovery equipment, generating dry steam. We don't want to put out a bunch of water with the steam. Automatic controls on the boiler, blowdown we'll talk about, alarms, etc. Distribution. We would really, if we have turbines, we would like to minimize the flow through pressure reducing valves, because that steam that we didn't get power out of a turbine if it goes through the PRV, so that can be important. Recover and utilize available condensate. Are we dumping condensate because of leaks in the system, or we just haven't installed all the piping? Are we recovering flash steam? All kinds of things. And then you total all this stuff up. And so there's 340 points in this document, and a typical score might be 222 for this guy. And so he got 65%. So I don't know, did he pass the test? Well, it's really not a pass-fail thing. It's just a tool of self-evaluation to maybe give you some suggestions on how to get better. Okay, I'm going to pause here for a second and save this file and see if this is actually working.